So you want to understand the phases of the moon, and you think somehow the globe can't explain the way the phases of the moon are, and the way the moon's orientation is, and that somehow the flat earth explains everything. Well, that just means you're insane. But we're going to go over some things about the moon that'll maybe help you see the light. You can see in this animation here that the moon goes around the earth over here once a month. You can see when the moon is behind the earth from the sun. That's when you have your full moon, full phase here. As the moon continues in its path around here, you start seeing the shadow pass in front of the face of the moon that faces the earth. As you can see here, that shadow is approaching the center. There's your half phase. Well, actually, that's your fourth quarter. And then we're approaching the new moon, where the moon is going to be in front of the earth, facing the sun. So that's where the phases come from. Everybody on earth sees the same phase of the moon. Right here, the new moon. The dark side of the moon is facing the earth side. Everybody on earth sees the same phase. But what about the orientation of the moon? What causes that? Let's take a look. So the first thing you need to understand about the sky is that everything in the sky revolves around the poles. We have the north celestial pole, where the North Star is. There's a south celestial pole, which is visible in the southern hemisphere. In the northern hemisphere, you can see stars in the southern hemisphere, but you can't see the southern celestial pole. And everything rotates in the sky from east to west. If we were to fast forward this a little bit, we could see that rotation. So the sun goes down in the west, stars are rising in the east, and they stay in their positions relative to all the other stars, including the North Star. They rotate through the sky until they get to the other the other horizon. Oh, that's too fast. And then they set in the west. And if you were to take a picture, long exposure, you see the star trails everybody's familiar with. They form concentric circles. If you were to look at this direction, this is the direction the star trails would take. If you looked over here, star trails would look like this. And in the south, they would look like this. So the moon follows the same course through the sky as everything else. Let's look at the moon. We'll back up and get the moon up in the sky. There's the moon. We'll go back to where the moon rose. That close to it. This is today's moon. So at my location, we'll see it rose at about 10 o'clock this morning. Because it's kind of close to the sun, being just a little bit past noon, I believe. Excuse me. So there's the phase as it was this morning. If I was to let's go ahead and just lock onto the moon here. If I was to advance to the current position of the moon, now we can see that orientation looks different than it did this morning. But what's actually changed between then and now? Let's go look at it again. So you see, as it moves through the sky, its orientation doesn't really change in relation to that grid. When it rose this morning, the side of the moon facing the sun is what is lit, and that's the east side of the moon, but it's facing what we would consider the west of the sky. So the moon has a north and a south and an east and a west, just like the Earth does. But that's not really important. What's important is that you can see right now that this side of the moon, which is the north side of the moon, is oriented towards the North Pole. And it stays oriented to the North Pole because it's not rotating. The moon is not rotating in the sky. What it's doing is it's following that course, and its orientation doesn't change in regards to the sky. It's constantly facing the same direction. The lit side of the moon facing towards the west, which is where the moon is headed in the sky, to the west. This side, the north pole of the moon, facing the north pole of the sky. South pole of the moon facing the south pole of the sky. And as it moves through the sky, the reason its orientation to us appears to change is because its azimuth is changing as well. As it moves through the sky, we're having to turn to face it in order to see it. Obviously, if the moon was behind you, you're not going to be able to see it unless you turn around, or you can bend over backwards and you can see the moon upside down. But what we're seeing is just the fact that we're having to turn along the ground here to face the moon. So wherever that moon is, it's still oriented north and south and east and west, just like it was before. But that position in the sky is what determines where we have to point along the azimuth. We turn on the azimuth grid here, you can see that now we're looking at 70 degrees. And if we continue to follow the moon, it's moving south in the sky, as well as getting higher. Speed this up a little more. So when the moon gets to its highest point in the sky, it's going to be due south. And once the moon is due south, we'll see, if we zoom in on it, that once again, the north side of the moon is facing north. This side here, the lit side, is facing to the west. The moon is still oriented just as it was before. The only difference now is that it's opposite the North Pole in the sky. So we're facing south to look at it. If we continue watching it move, it's going to head towards the west. It's still oriented the same direction. North is north, south is south. But now as it gets towards the horizon, the west side facing of the moon is pointing down towards the horizon because that's where it's going. So no matter where you are on the earth, when you look at the moon, you're seeing the moon oriented the same as everybody else. The north side of the moon is always going to be facing north. The south side of the moon is always going to be facing south. The east and west sides of the moon will always be facing east and west. The only difference is which way you have to turn on the earth to look at the moon. Now let's take a look at how this works on your flat earth model. So here we have the broken flat earth model. We see the sun lighting the moon, and we see that it says in the northern regions this is what you're going to see, and in the southern regions this is what you're going to see. So at the North Pole, I guess, where this arrow starts, maybe, you're going to have an almost full moon, and then from the south ice wall, the moon is just a little bit past new, I guess. And I would imagine if we were to be looking from various positions, they would all be seeing a different phase, and at different times of the day. Even the phases would be changing as the moon went past, except maybe on the equator. I guess, well, no, on the equator, I guess when the moon went overhead directly, you would only see like a half lit moon, and then you might see a full moon as it passed. So this model doesn't match reality at all. It doesn't even claim to. It claims that the image or the view of the moon is going to be different in the south and the north, which is not true at all. You're going to see the same phases of the moon no matter where you are, and that's just a fact that's indisputable. So I don't know why this video goes on for an hour and shows nothing but this for an hour. I imagine this is something that you could put in front of a small child, maybe when they're getting ready to take a nap, and then they would just be brainwashed into thinking that the earth is flat. So I don't really see much other use for it, really. But I'm sure there's a really good reason somebody made an hour-long video of just this. But honestly, it doesn't prove anything at all, except that the flat Earth doesn't match reality. So the moon phases that you see in time and date are calculated the same way that they are in stellarium. Basically, they know what direction the moon is. You have to face west southwest here to face the moon, and they know which way is north, which way is south. They're able to figure out the angle that you're going to see the moon at, in addition to the phase you're going to see when you look at it. And this is going to be accurate for any location that you pull up. You can check that yourself. But again, the flat earth model that you gave me does not predict this at all. Not one bit. The moon don't be how you think it do. Womp womp.